Okay, this is our first worked example for this topic, and I would classify this as a sort of standard demand question, nothing too complicated, but quite a common structural question. So let's see how we go about it. A carriage has come down a roller coaster slope and has reached a final velocity here. It's got a mass of 300 kilograms and it's gone down a vertical distance of 48 meters. It's told us that the final kinetic energy is 40% of the decrease. That's important. Usually we'd assume that all of the kinetic energy, all the G.P.E has changed into kinetic energy, but that's not the case here. Some of it has been lost along the way as thermal. So, firstly we need to do is calculate how much gravitational potential energy it's lost along the way. Now, the important thing here is the change. We could calculate how much G.P.E it's got here and how much G.P.E it's got here, but that's not necessary. We just imagine how much work it would do to take it from this point to this point using our G.P.E equation. So that's going to be mass times by gravitational acceleration times by the change in height, which is going to be 300 times by 9.81 times by 48 meters. That's going to give us 1.41 times 10 to the 5 joules. That's a 5. And so if we've got 40% of that at the end as kinetic energy, then our kinetic energy is going to be that, but 40% of it. So to get 40% of that number, we simply need to times it by 0.4. which will give us a final kinetic energy of 5.65 times 10 to the power of 4 joules. So how do we get the velocity from that? Well, we also know that the equation for kinetic energy, which links it to velocity, is half mv squared. We can make that equal to our 5.65 times 10 to the power of 4. So, rearranging slightly, we're going to get v squared is equal to 2 times that, because we're taking the half to this side, timesing both sides by 2. 5.65 times 10 to the power of 4, and then it's divided by the mass. We've divided both sides by 300 to get rid of the mass. So v squared equals that, which leaves v equaling the square root of that. Divided by 300. So our final velocity will be approximately 9.4 meters per second. Now, there was another way we could do this question using symbols, which just keeping the symbols without putting them into numbers, which makes it a bit more sort of elegant. And by doing that, we could just equate at the very beginning the mg change in h is equal to 40%, 0.4 of the half mv squared. Now if you notice here, the masses will cancel, so we get v squared is equal to 2gh divided by 0.4, and then we could root that to get out exactly the same answer as last time, but a little bit more elegant.